Okay, so let's continue. We'll study quadratic equations. So let a be reals with a not equal to 0. We can ask, can we solve the linear equation ax plus b equals 0? Can we solve this simple linear equation? So note that saying ax plus b is equal to 0 is same as saying ax is equal to minus b. So which is same as saying x is equal to minus a inverse b. So we can say hence the solution, there's only one solution, hence the solution of ax plus b equals 0 is x equals minus a inverse b. Hence we can solve equations of this form ax plus b equals 0 when a is non-zero. So we'll try to go ahead. So let a, b, c be reals. Let a, b, c be reals, a not equal to 0. We can ask, can we solve the quadratic equation? So the above equation is called a linear equation because you are only having x power 1 term appearing in the equation. So we can ask, can we solve the quadratic equation? So ax square plus bx plus c is equal to 0. Can we solve this quadratic equation? So by the way, so we call it a quadratic equation because the highest power of x which is appearing is 2, x square. The highest power of x which is appearing so this is an equation involving x square and x, and the highest power of x which is appearing is x square. Hence we say this equation is a quadratic equation. So we can ask, can we solve this quadratic equation ax square plus bx plus c equals 0? So let's try to solve this equation. Let a, b, c be reals with a not equal to 0. Note that, so saying ax square plus bx plus c is equal to 0 is same as saying, because you can divide by a, so x square plus b by x plus c by a is equal to 0. Saying this is same as saying x square plus b by x plus c by a equals 0. Now there's one key observation we can make, which is x square plus b by x. These are the first two terms. These are the first two terms of x plus b by 2a whole square. So this is the key observation. So in this equation x square plus b by x plus c by a equals 0, x square plus b by x are the first two terms of x plus b by 2a whole square. Hence we can write, so saying x square plus b by x plus b by a equals 0 is same as saying x plus b by 2a whole square minus b square by 4a square. So this minus b square by 4a square removes the third term in the expansion, and you are left with the first two terms of x plus b by 2a whole square. So those are, so these two so these give x square plus b by a x, so plus c by a equals 0. So we are saying x square plus b by a x plus c by a equals 0 is same as saying x plus b by 2a whole square is minus b square by 4a square plus c by a is equal to 0. And then we can simplify. So this is same as saying x plus b by 2a whole square is equal to b square minus 4ac by 4a square. So we have simplified this ax equal plus bx plus c equals 0 statement into a statement which is more manageable. X plus b by 2a whole square is some b square minus 4ac by 4a square. Now we can try to solve this equation, this simplified equation. We have case 1 where this term b square minus 4ac is greater than or equal to 0. So in this case, the equation, the simplified equation x plus b by 2a whole square is equal to b square minus 4ac by 4a square. This simplified equation has two solutions. So not necessarily distinct. So these are two solutions. X plus b by 2a equals plus root of b square minus 4ac by 4a square, and these are the two solutions. X plus b by 2a can be minus of b square minus 4ac by 4a square. I think we already looked at the equations of the form use alpha square equals beta. So equations of the form alpha square equals beta have solutions. Alpha equals minus root beta and alpha equals plus root beta. This we get by factorizing. So x square minus a, yeah, here. So what are the solutions of x square equals a? These are x equals root a or x equals minus root a. We just get it by bringing root a square to the left and factorizing. So the solutions of x plus b by 2a whole square equals b square minus 4ac by 4a square are x plus b by 2a equals plus root of b square minus 4ac by 4a square, and x plus b by 2a equals minus root b square minus 4ac by 4a square. Hence, so in this case where b square minus 4ac is greater than or equal to 0, hence the equation ax square plus bx plus c equals 0 has two solutions. So these are not necessarily distinct. For example, b square minus 4ac can be 0. So you have two solutions. The solutions are given by x equals the above x's, right? So x equals minus b plus or so minus b plus root b square minus 4ac by 2a. You have two solutions. X equals minus b minus root b square minus 4ac by 2a. So when b square minus 4ac is non-negative, in this case we have two solutions for the quadratic equation, not necessarily distinct. So these are the two solutions. These are the two possible solutions. X equals minus b plus or minus root b square minus 4ac by 2a. So now we can consider the other case. What is the other case? The other case is b square minus 4ac is negative. So this is a simple case. In this case, the simplified equation, the equation x plus b by 2a whole square. So this is the simplified equation. X plus b by 2a whole square is b square minus 4ac by 4a square. In this equation, this term is negative. Hence, this equation has no solutions. Something squared equals some negative thing that won't have any solutions. This has no solutions. Hence, in this case, the equation, the original equation, ax square plus bx plus c is equal to 0 has no solutions. Okay, so to summarize, this is what we got. So we have this equation ax squared plus bx plus c equals 0, where a is non-zero. Here you have two cases, b square minus 4ac is greater than or equal to 0, or b square minus 4ac is less than 0. These are the two possibilities. When b square minus 4ac is greater than or equal to 0, the solutions are x equals minus b plus or minus root b square minus 4ac by 2a, and when b square minus 4ac is less than 0, the quadratic equation has no solutions. Okay, so this is the result we got, and the key step was simplifying ax square plus bx plus c equals 0 as x square plus b by x plus c by a equals 0, and observing the first two terms can be sort of clubbed. They are the first x square plus b by ax, they are the first two terms of x plus b by 2a whole square. Hence we get an equation of the form x plus b by 2a whole square is some number, and by casework we see that this simple equation has solutions when b square minus 4ac is greater than or equal 0, and no solutions when b square minus 4ac is less than 0. So this is how we can solve a general quadratic equation. So just to consider some examples, consider the equation. So we can ask so we can keep asking questions. We are able to solve quadratics. What about cubics? What about fourth degree polynomials? And so on. So those are very difficult questions in general. In any case, this is how we solve quadratic equations. So consider the equation 3x squared minus 2x plus 1 equals 0. We can ask what are the real solutions. So we're only talking about real solutions. We haven't yet. So later we'll look at a number system called the complex numbers, over which we can also consider the equations of the same form, and they will always have solutions. In fact, even more general higher degree polynomials, they will have solutions. They will have solutions. It's called the fundamental theorem of algebra. And so we look at the complex numbers and the fundamental theorem of algebra later. Okay, consider the equation 3x square minus 2x plus 1 equals 0. What are the real solutions of the equation? So we just need to look at b square minus 4ac. So b square minus 4ac is minus 2 square minus 4, 3, 1, 1. So 4 minus 12 is minus 8. So b square minus 4ac is negative. Hence, the equation has no real solutions. So we can consider another equation. Consider the equation 2x squared plus 3x minus 4 equals 0. We can ask what are the real solutions of the equation. So we can look at this b square minus 4ac term. So b square minus 4ac is 3 square minus 4, 2 into minus 4. This is 9 plus 32. This is 41. This is positive. Hence, the solutions are, so x equals minus b plus or minus root b square minus 4ac by 2a, right? So this is minus b minus 3 plus or minus root 41 by 2 times a is 4. So these are the solutions. That is, x equals minus 3 plus root 41 by 4, and x equals minus 3 minus root 41 by 4. These are the two possible solutions. These are the two solutions of the quadratic equation 2x squared plus 3x minus 4 equals 0. So these are two straightforward examples, and right. So that's all for this part. See you in the next part.